Good everyone, welcome back to our topic differentiation. Today we will be continuing our discussion on the topic product rule and we'll be treating some questions on trigonometric function. Our first question is from NECO 2005. It states that if y equals to s sin 2s, find the y over the s. Our first step is to write down our equation y equals to s sin 2s. And since s is multiplying sin 2s, we know we are going to be using product rule. And from product rule, the y over the s is equal to u dv plus v du. U will be equals to s. The u therefore will be equals to 1 because when we differentiate s, we will get 1. V will be equals to sin 2s. And when we differentiate v, the v will be equals to 2 cos 2s. The next step is to substitute u, the u, v and the v in our formula. Substituting them, the y over the s will be equals to s, which is u, times 2 cos 2s, which is the v, plus sin 2s, which is v, times 1, which is the u. Multiplying at, the y over the s will be equals to 2s cos 2s plus sin 2s. 2s cos 2s plus sin 2s is same as sin 2s plus 2s cos 2s, and our correct option is E. Our next question states that if y is equals to s sin s, find the y over the s when s is equals to pi over 2. Now in our solution, we are writing out our equation y is equals to s sin s. Let y be equals to uv, obviously representing product rule. The y over the s will be equals to u dv plus v du. Our u is equals to s, therefore du will be equals to 1. And v equals to sin s, therefore dv will be equals to cos s. The derivative of sin s is cos s. Now substituting for u, du, v and dv in our formula, the y over the s will be equals to s cos s, that's s times cos s will give us s cos s, plus sin s times 1, which is therefore be equals to s cos s plus sin s. At this point, we are going to substitute s to be equals to pi over 2 in our equation. And we know that pi over 2 in degree is 90 degree. Substituting in our equation, it will be equals to pi over 2 cos 90 degree plus sin 90 degree. Cos 90 degrees equals to 0 and sin 90 degrees equals to 1. This make our equation to be equals to pi over 2 times 0 plus 1. Pi over 2 times 0 will give us 0, so we are just left with 1, and our correct option is C. We have another question that states that differentiate with respect to s sin s in brackets 1 minus cos s. Now the first thing we are going to do is write down our equation y equals to sin s in brackets 1 minus cos s, and since they are multiplying themselves, we are going to be using product rule. And our product rule formula is the y over the s is equals to v du plus u dv. Now let u be equals to sin s and v be equals to 1 minus cos s. Du will be equals to, that is differentiating sin s to be cos s, and dv will be equals to sin s, because if we differentiate 1 minus cos s, it's going to give us minus sin s, which is equals to sin s. Now substituting for u, v, du and dv in our original formula, the y over the s will be equals to 1 minus cos s in brackets, which is v, multiplying cos s, which is du, plus sin s, which is u, multiplying sin s, which is dv. Doing so, our final answer becomes the y over the s will be equals to 1 minus cos s in brackets, multiplying cos s plus sin square s. Our question is a case involving product and chain rule. It is from UME 1999. It says that what is the derivative of t square sine in bracket 3t minus 5 with respect to the variable t, and we are given the option. Let y be equals to t square sine 3t minus 5 in bracket, and we are to find the y over the t. Now since t square is there and sine carries another function of t, Their differential is that of product rule, and we know that we are going to make t squared to be u and sin 3t minus 5 to be v. And our formula for product rule, dy over dt, will be equals to u dv plus v du. Now we can easily get du because the derivative of t squared is equals to 2t, so our du is equals to 2t. Now to get our dv is a function of a function problem. I'm going to be solving for dv using function of a function. Let y be equals to sine in bracket 3t minus 5. That's our v. Making z to be equals to 3t minus 5, the z over dt will be equals to 3. While y equals to sine 3t minus 5 in bracket will becomes y equals to sine z, and dy over dz will be equals to cos z. Thus, dv, which is equals to dy over dt, will be equals to dy over dz times dz over dt. dy over dz is cos z and dz over dt is 3. So multiplying cos z times 3, we are left with 3 cos in bracket 3t minus 5 as our dv, because we are going to replace z to be 3t minus 5 in the final equation. Now at this point, we've gotten our dv and we've gotten our du. We are going to be substituting for them in the original equation. Doing so, dy over dt will be equals to t squared times 3 cos in bracket 3t minus 5 plus sine in bracket 3t minus 5 times 2t. Multiplying, this will be equals to 3t squared cos 3t minus 5 plus 2t sine in bracket 3t minus 5. Now rearranging our final answer to meet the form in our options, it will be equals to 2t sine in bracket 3t minus 5 plus 3t squared cos in bracket 3t minus 5. Our final answer is C. We have another example from a case involving product rule and chain rule. It states that differentiate with respect to s sin s ln in bracket s squared. The first thing we are going to do is write down our equation y equals to sin s ln in bracket s squared. And since they are multiplying themselves, we know we are going to be using product rule. Our product rule formula states that dy over ds is equals to v du plus u dv. Sin u will be equals to sin s and v will be equals to ln in bracket s squared. Finding du will be equals to cos s, because when we differentiate sin s, we get cos s. But we are going to be using chain rule to find dv. V is equals to ln in bracket s squared. So we are going to be making our bracket to be equals to z. So let z be equals to s squared. V will be equals to ln z. Now the z over the s, that is differentiating z with respect to s, will be equals to 2s, and the v over the z will be equals to 1 over z. That is the derivative of ln z is 1 over z. Now our chain rule formula states that the v over the s is equals to the v over the z times the z over the s. Now substituting for the v over the z and the z over the s, the v over the s will be equals to 1 over z times 2s. Now substituting z to be equals to s squared and multiplying, the v over the s will be equals to 2s divided by s squared. 2s divided by s squared will be 2 over s. Therefore, the v over the s is equals to 2 over s. Now we've gotten our du and we've also gotten our dv. Now substituting for u, v, du and dv in our original equation, dy over the s will be equals to ln in bracket s squared times cos s plus sin s times 2 over s. Therefore, multiplying out, dy over the s will be equals to cos s ln in bracket s squared plus 2 sin s divided by s. We have some exercises for you to attempt at home. The answers to these questions are found in our Hidden Facts for the Mathematics textbooks. You can easily get the hard copy, or if you are interested in the soft copy, you can get it at the website in the bottom of the screen. Thank you.